Okay, we are here for video lab number 17. It is the last video lab of the year. Excuse me. Okay, your name?
Opal.
Kyle.
Avery.
Al. You got to think about that.
Shama.
Okay, who can tell us what's the lab about today? Yes, Adrian.
Electrolytes.
Electrolytes. First of the Doug questions. What do we mean by an electrolyte? What is an electrolyte?
You can pass electricity through it
By doing what to it?
by adding something to it.
By doing
Adding water.
adding water to it. So it's a chemical that you're going to dissolve in water, and once you dissolve it, if electricity can go through it, then we call it an electrolyte. Now, when it dissolves, it produces something that enables the electricity to go through the water.
Iron.
Ions. And these ions have charges to them. What are the charges that you find?
Electrical charge.
Specifically, what type of charges?
Negative and positive.
Negative and positive, okay? Now, if the electrolyte produces a lot of ions, what kind or type of electrolyte is that called? It's got a lot of ions. It's called a strong electrolyte. How about if it only produces a few ions?
A weak electrolyte.
And how about if it doesn't produce any ions? A non-electrolyte. So what we're going to do today is we have a bunch of chemicals that are in front of you right now, and we're going to be testing, once you mix it with water, whether or not those chemicals can conduct electricity. So Opal, if you would turn your paper over so we can see what is your chemical. And Opal is working with NaCl. Who can tell me what that is more commonly called? Salt. And who can tell me how you would say that in chemical ways?
Sodium.
NaCl. Got half of it. NaCl. Yes. Sodium chloride. Okay. And what are you working with, Kyle? Kyle's working with C6H12O6, which is more commonly called sugar. Okay. Avery is working with MgSO4, more commonly called
Epsom salt.
Epsom salt. Now, here's a possible duck question. MgSO4. How do you say that in words? MgSO4.
Magnesium sulfate.
Yes, very good. Okay. Ralph has got NaHCO3, which is more commonly called baking soda. Who can give me that one in words? NaHCO3.
Sodium hydroxide.
No, you got the sodium part right.
Sodium hydrochloride.
No.
Sodium
HCO.
hydrocarbonate.
We're getting there. We're getting there.
Sodium hydrocarbonate.
Okay, you got the sodium right. You got the carbonate right. You got to get rid of the hydro and replace it with something else. Something in between the sodium and the carbonate. But it's not hydro, even though it's an H.
Bicarbonate.
Yes, sodium bicarbonate. Okay, and Shama, you have H2O, which is more commonly called.
Water.
And what's another way of writing H2O?
HOH.
Okay, so we now know what chemicals we're working with, and how much water should we use to mix them up?
100 milliliters.
100,
100.
which is 2 fifties.
250.
2 fifties make 100. Okay, now there are 3 sinks around this room right now. I want you to take out that bottom beaker and go put in 100 milliliters.
Yeah.
Hey, mine coming out. Got my fingers on it.
So was it difficult getting up this morning?
Very.
With the time change? My God. Why do they change the time?
Leave it alone.
I know it. Do we really care if it's a little bit dark in the morning? We'd rather be sleeping that hour.
Right.
Yeah. That's why it's dark, because you're supposed to be sleeping. All right, so we now have 100 milliliters of water. I want you to take a level teaspoon of the chemical that you're working with, dissolve it into the water, and then swirl it around so we can get some ions being produced, and then we'll test it out, see if it works.
Come on now.
Kyle, you made a mess.
Okay, now all of the people that are in our lab group today, they have 2 conductivity testers with them. In fact, we have 4 different kinds of conductivity testers. If you would take the stuff out of the boxes so we can see what you have. Opal, hold up the blue box that you've got there. That's one type of a tester. Okay, you don't have the blue box. You've got the one with the little what? The little blinking light on it, okay? But you've got the blue box, all right? Okay, and who's got the one with the buzzer?
I do.
So hold up your buzzer so we can see what your buzzer looks like.
Ta-da.
Okay, it's got a little buzzer on top of it, and hold up, Shama, the one that has all those little pretty lights on it and numbers that go along with it, all right? Now, they all work exactly the same way, okay? They're all broken at their electrodes. Okay, Kyle, if you could hold up your two electrodes and show us where is it busted on the blue box? Right there. In order for this to work, electricity has to go into one of those electrodes, through the solution that you have made here, if you did make a solution, back into the other electrode, and then completing the circuit. How will we know if the circuit has been completed?
If the light lights up?
Yes, if the light lights up. Now, what do we call the type of circuit where if you break it at any point in the circuit, the whole circuit shuts down?
Serious.
A series circuit. So you have a series circuit in front of you right now. All right, so what we're going to do, it's good what you've done. You don't have to keep doing it. We're going to take the one with all the pretty lights on it. Since everybody's got one of those, you're going to push the button that says hi, not until I tell you. I'm going to go to you one at a time, and you're going to face it towards the camera so we can see what light went up, and then you're going to look to the side of it and tell us what number the light is. So, Opal, you're working with salt water. Press the top button and put it into the thing, and tell us what's the highest light that you've got lit. What number?
9. No, wait, 10.
10. So that's a pretty strong electrolyte because it's producing a lot of ions so that the top number, which is 10, is lit up for you. Okay, now you've got sugar water, so put yours in, and let's see what your light comes up to be.
It won't go in.
You have to push the button.
It's stopped.
There it goes, it's there. And what light do you get coming up on that one?
6.
6. Oh, it went down. Now what do you got?
5.
5. So that's not a real high number out of 10. So it's somewhere at this point between weak and non. We'll have to do a further test on it. You're testing out Epsom salt. So let's see what happens with you. Okay, and Avery, can you see the number?
8.
8.
Now it went down to 7.
Okay, so you're kind of at a weak zone right now, all right? But close to strong. And you're testing out baking soda. Let's see what your light comes up. What do you got there?
10.
10. You win the Cupid doll. Okay, so that's kind of strong at this point. And you're testing plain water. You got to push the button. You got to hold your finger on the button. Okay, what number is it at now?
5.
5. Oh, it just went down. Take a look now, Shama.
4.
4, so that's not a real strong number. Now we're going to test it with the other piece of equipment, and don't do it until I tell you, okay? You've got the one that has the blinking light, so put yours in and let's see if it blinks. Is it blinking?
Yep.
Okay, so if you had a choice right now, Opal, of whether this electrolyte is either strong, weak, or non, what would your answer be?
Strong.
Strong, because the strong electrolyte makes the light blink. Okay, you're going to put in the blue box now to test the sugar, and what's the deal on your light, Kyle?
It's not.
It's not on, so what's your choice?
Non.
Non-electrolyte. You're testing the Epsom salt. Make sure your light is turned on. Place it in. And what type of a light is coming on right now, Avery?
Dim.
Dim, real dim. So what type of an electrolyte is it?
Weak.
Weak. Okay, now you're testing out the baking soda, and you got the buzzer. Is it buzzing?
Yeah.
So that must be you that's making that strange noise then, right? You want to go to the bathroom? So what type of an electrolyte is it?
Strong.
Strong electrolyte. And you're testing out water with the light. You have to take the battery out of that. Okay, what's happening to your light, Shama?
It's not coming on.
Not coming on, so what can you tell us about the type of electrolyte? Non. We know electricity doesn't go through water. Okay, so you've gone through your test correctly. Now, next question. What part of the experiment that they just did is considered to be the control to the experiment? Brian?
The amount of
What part is the control? Tehran?
material they put.
No,
Oh,
what
the
part
amount.
is the control?
The amount of chemical that they put.
Nope,
I know,
what
I know.
part is the control?
And water to
Not really.
The plain H2O.
The plain water. Who has that? Shama's one is the control. What's different about Shama's beaker than anybody else's beaker?
Because hers has no added chemicals.
Right. She has no variables at all in her beakers. So the standard, what everything is based on here, is based on Shama's water. Okay? So the thing that has no variables and becomes the standard for the experiment, that's called the control. So the water is the control. All right, now, next question for you. You ever drink any of these sports drinks, like Gatorade or something? Anybody here have any of those sports drinks around?
I do.
You guys do? Take it. Let's see what you got. Okay, what's the name of your sport drink there, Dante?
All sports.
And what do you have? You have just a label? You just walk around with labels? What's wrong with you? Read the labels. There's something on the ingredients that has something to do with today's lab. What's it say, Dante? Electrolytes. What does yours say? Electrolytes. So in other words, these drinks that you drink, these sport drinks, they contain electrolytes like you've been testing out. Let me explain how it works. When you're involved in some sort of physical activity and you're sweating a lot, you're losing salt. Remember we talked about sweat has salt in it, right? Those salts are electrolytes that your body needs. By sweating, you're losing the salts. So by drinking these drinks, you're putting those salts back into your body. You're replenishing your electrolytes. Okay? So there really are electrolytes in those drinks. And in fact, a couple of years ago, we tested them out with the equipment, and they came out to be weak electrolytes. Electricity actually passed through it, and the light came on to be dim. Okay? So these are examples of how electrolytes are used in your daily life. All right? So you got through the first part of the lab very well. We have a good shot at getting you...
Is only the first part?
Yeah, the second part has to do with your talents, remember? But today's talents have to do with sports. How many of you are into sports? How many of you know what today is in terms of the sporting world?
Baseball season opening.
Yes, the baseball is opening up today. How many of you play baseball or softball? How many of you have ever been on a team? How many of you have ever been to a major league game? How many times have you been to a major league game?
3 times.
3 times. Anybody more than 3 times? How many?
6.
6. Anybody more than 6? 6 is the most in the class? Kerry, you have a chance now to save this class. Okay, let me explain what you're going to have to do. It has to do with a story. 7 years ago when we first began teams, we had a kid from Peru on our team. Okay, and he didn't speak any English. But he knew about baseball. And he knew about the Yankees. Everybody knows about the Yankees. Except he didn't call them the Yankees. He called them the Jankies. Because people have trouble saying Y's and J's. So we said to him, you know about the Jankies? And he said, yes. Get that? Yes. So he decided one day that he was going to go down to the Bronx and go to a Yankee ball game, okay? I think his name was Jose. And he went down there, and we were kind of worried about it, because if you've ever been to a game in Yankee Stadium, the Bronx is a kind of rough neighborhood to be walking around and not know how to speak English, right? So when he came back the next day through our interpreter, that one of the kids could speak Spanish, we asked him, we said, Jose, how was the game? How did the people treat you? And he said, well, the game was really good, and they treated me really nice. They were very kind to me. They cared about me. We looked at each other and said, Jose, did you go to the Yankee Stadium? How do you know that they cared about you, Jose? So he said, well, before the game began, everybody in the whole stadium, they stood up, they looked at him, and they went, Jose, can you see? Right? So that leads us, Kerry, to you. Because, Kerry, you have seen more ball games in the major leagues than anybody else in this class. Therefore, you have heard the Star-Spangled Banner more than anybody else in this class. Therefore, if you can sing the Star-Spangled Banner for us, this class has a good chance of winning.
Nope.
You can't sing it.
Carrie,
Can you believe that? All right, just say, Kerry, why can't you sing it for us?
'Cause I don't remember it.
You don't know the words? Okay. Sort of like a hummingbird, right? That's why a hummingbird hums, because it doesn't know the words. Who has a planner with them? The planner has the words to the Star-Spangled Banner.
I sing it.
Ah, now he's not singing it. Do we have somebody who can sing it for us? And if for some reason you get a little, lost on it, the rest of the class will help you out.
No. Yo, look at me.
People want to keep their eardrums.
Amy!
Anybody?
I don't feel like
I'll do it.
All right, Keish. Keish is going to save the world. All right, now listen, Keish. Here's what we'll do. Give her a,
Carrie, go in my book bag. It's right there.
give her one of the planners. This way you can read it right. And Keish, if you get lost, the rest of the class will help you out.
Enough laugh.
Should be in the front flap or something. Okay? All right, quiet down now, everybody. She's going for the money. Keish, let me help you out. Here's the first word. Oh. Go for it.
Okay. Oh, say, can you see?
You got to sing it.
Oh, say, can you see by the dawn's early light what so Bradbury Hill at the twilight's last gleamings, whose broad stripes